You want to talk nice to your computer, because if you talk mean to them, they just don't. Who's that little Alexa? I asked, my son-in-law has it upstairs. I asked her to play a song and she doesn't respond because my voice is kind of raspy. I think she's programmed to ignore people who talk mean to her. I said, play some cowboy music. I don't know cowboy music. Okay, we're on page 44 and talking about the greenhouse effect. And let's see. Let's just come up here. Oh, let me turn this on so you can see what's going on. And let's just come up here and let's just click on Chrome. Somebody told me that we can get the kind of stuff I get at home if we click on Chrome. Let's see what happens. And let's just Google greenhouse effect. And which one do I want? I don't know, so I'll click on this one. Greenhouse effect. The trapping of the sun's warmth in a planet's lower atmosphere. Can you see that up there? Due to the greater transparency of the atmosphere to visible radiation from the sun than the infrared radiation emitted from the planet's surface. What are they talking about? Do any of you have a greenhouse at home? Have you ever seen a greenhouse? So, what? The sun comes through it, but it doesn't let all the heat from the sun escape. Well, the other day when we looked at our atmosphere, that little thin piece of paper that's up above the earth, that's about how tall the atmosphere is in terms of the part that makes a difference in our life. Gotcha, Adrian.
Thanks.
We're on page 44, talking about the greenhouse effect. And let's see. We could look at NASA climate for kids, but let's just keep moving down here till we find the one that I found. Greenhouse effect. This is the one I found. You go, Wikipedia? Yeah, it's as good as Britannica. Just don't let people talk you out of it. My wife goes, you can't trust Wikipedia. I said, you can't trust Britannica either. You know, they lie in both of them. You just have to. So here's a picture of the greenhouse effect. The process by which radiation from a planet's atmosphere warms the planet's surface to a temperature above what it would be without it. If we didn't have our atmosphere, we wouldn't have what we need to live on this earth. So that's why people get a little alarmed about the fact that what we need to live is this little coating around us. Remember I told you that one of the guys on the internet said that if the earth were the size of an apple, the atmosphere would be about the thickness of the skin of the apple. And that little skin is what makes life livable for us on this planet. Without it, we would be like the guys out in the space station, or like the guys who walked on the moon, having to have all this kind of artificial stuff to live with. So that's why people get alarmed about things happening to it and it being damaged. But these pictures over here is the reason I picked Wikipedia. You kind of get the drift of what's happening here. Radiation from the sun's coming down, and some of it goes back into space, but most of it stays right here on the earth. And then the stuff on the earth, remember we saw the picture earlier in the book about the circulation from stuff on the earth? You know, we're breathing and we're sucking in. Have you ever walked into a classroom that was full of people and the doors were shut and they just dismissed the class and you go, whoa. Well, you just walked into a big cloud of carbon dioxide, because the people in there have been sucking all the oxygen out. I mean, they're not just going trying to, they're just normally breathing, and it's filling the room up with carbon dioxide. So you want some fresh air to come in, so there's oxygen there. Well, that's what's going on here, and this stuff is coming around, and this heat's coming in from the sun, and all you have to do is go outside, and if you're standing outside where it's cold, you just walk around where you're in the sun and out of the wind, and all of a sudden you start getting warmed up outside. So that's what they mean by this greenhouse effect. What's the next picture on here show? There's another picture of the sun's rays coming down. And see, some of them are bouncing off of the atmosphere, and some of them bounce off of part of the atmosphere, but some of it comes in here and then goes back out into space. Now, think about it. Here are those guys up there. Where? Up in here somewhere, floating around in that space station. Why is it so cold out there? Because they don't have the atmosphere producing the heat that keeps us warm down here. All right, and I think there's one more picture in here that I want you to look at. And all you have to do to find this stuff is just take these labels in the book, like page 44, greenhouse effect, and just Google it. Now, granted, I spend a lot of time clicking through them till I find the best ones to show you in class. But now that I've shown it to you in class, you make a note, say, Wikipedia had some cool pictures and some good explanations of the greenhouse effect. And just cool stuff. And then they talk about it. And it's just a lot of interesting and helpful reading when you're trying to answer. I don't know if you know this or not, but when you're answering those questions at the end of the chapter, if the stuff in the chapter, because if this book had everything that was available, it would be about 3 or 4 times as thick. So if they don't give you very much information, just Google the question and see if you find some stuff that helps you understand it. And some of the stuff, when you're trying to understand it, you'll go, you know, it's still kind of beyond me. You know what I mean? It's just like, I know what they're saying, but I'm not sure I completely follow it. It's kind of like, did you ever take a math class where the guy who was teaching math had been through it quite a few times, so he had a handle on it, but you just kind of got lost after a while? And that's the same with geography, because we're studying the globe, the earth, the solar system that God has made, and by the way, mathematics. This system was made with mathematics, and that's why mathematicians discover all this cool stuff. I remember I think it was Calculus 3 at the university, my calculus teacher said, did you know that hawks are just as smart as you guys are in this class? And he said, you're going to study a curve that the equation for it is rather complicated, and you've never studied it before because you don't get to study it until you take Calculus 3, and it's called a cycloid, and it's a perfect curve that a hawk flies when he's catching a rabbit on the ground. He starts coming down, but see, if he just kept going at a straight angle, he'd catch the rabbit, but he would crash into the earth and break his beak and get a headache, and who knows what else he'd do to himself. So he follows this curve that brings him down and then around and picks up the rabbit and takes off. And they've photographed that curve and given an equation to it, and it's called a cycloid. And all this stuff, even around the shore of the ocean, these are fractals that are going around there that mathematicians have figured out formulas to show how these fractals are developed. See, God just put this whole system together with mathematics. And just like sometimes math gets a little overwhelming, geography can get a little overwhelming too. So when you come to these topics, just go, hey, I'll go look up, I'll Google this stuff if I'm having trouble understanding it. On page 44, they talk about latent heat and sensible heat. Okay, now when I say sensible heat, the first thing that comes to my mind is heat that makes sense. So does that mean latent heat doesn't make sense? No, it's not make sense. Sensible heat is heat that you can sense with your physical capacity to register heat. Like right now, do you sense the heat in this room? Is it a little warm, or is it a little cool, or is it about right?
It's about right.
It's about right? See, for me, it's a little warm. Is it warm for you? So maybe we need to turn down these thermostats so they don't heat this room up so much. But where are these little units against the wall getting the heat that they're sucking into this room? Anyone know where they're getting it? Either from outside, you go, what? It's cold outside. Yeah, they compress the air and get the heat out of it and bring it inside, or they have little coils inside that are electrical that generate heat that they blow around the room. And it's just like, okay, so, and the book uses a good illustration. You see an ice cube, and that ice cube is full of heat. It's like it is, but it's called latent heat because you don't really sense it. But if you put the ice cube in your hand and hold it, and it starts to melt, then where it's melting, well, what happens if you hold an ice cube? Your hand feels cold. So you sense that heat that was in the ice cube, and it's like, what's happening? Well, if the ice cube's turning into water, in order for it to go from the solid state to the liquid state, it needs heat. So where's it getting the heat to turn into water? From your body, 98.6, and it's just sucking it out of you and turning it into water. And as I said the other day, if you held your hand there long enough with that pool of water from the ice cube, if you stood around for 2 or 3 days, the water would evaporate and turn into water vapor that goes up into the sky, which brings us to page 47. But before we look at that, look at page 46. There's a picture on page 46 that I want you to look at. See how the sun shines on a hot sandy beach, and heat rises from the earth, and that draws cool air from the water around the island. It looks like this is an island, and so it causes this cycle of air just circulating around from the water coming into the land and going up. And what happens as the air goes up? As it goes up, it cools off, and then as it cools off, it falls back down, and again it forms these little curves over, and it falls back down over the water. Then it comes back in again because the sand is so hot. The same thing can happen. You can be in a parking lot out in the middle of what you would call a grassy area. Okay, like for example, this car lot next door where they sell cars. A guy who works there could walk out in the middle of that parking lot on a hot sunny day, and because so much of this parking lot is surrounded by grassy area, he would feel a cool breeze. If he stopped and thought about it long, he would feel a cool breeze coming from our campus and coming from that grass on the north, and coming over and going up over the concrete, and then going up in the air and curving around, cooling off and falling back down and coming in again, and just forming that cycle. And you can do that any place where you find a church parking lot would do the same thing. If you have a lot of wooded area around a church parking lot, you can go out there on a real hot day, and you can feel, if you stand there close enough to the edge where if there's enough wood steep enough, you can feel a cool breeze coming through the trees because of just the air circulating. So that's a good picture on page 46 to help you understand how this circulation is going on here on this earth. Page 47 talks about precipitation. Have you experienced any precipitation recently? What do you call precipitation?
Let me look it up.
You don't know. Well, I'll type it in. Precipitation. P-R-E-C-I-P. How did I spell that? I-T-A-T-I-O-N. Too many P's in there. I-T-A-T-I-O-N. Precipitation. Let's just go up here and Google it. So, did you find out what it is?
Rain, snow, sleet, or hail that
What?
falls to the ground.
It's what?
Rain, snow, sleet, or hail that falls to the ground.
Rain, snow, sleet, or hail that falls to the ground. So, do you know anything other than rain, snow, or sleet that falls to the ground? The ice cube melted in our hand, the water melted, turned into water vapor, went up into the air. Now, watch what happens. As it gets higher up in the air, the higher up you go, the colder it is. Have any of you discovered that? Have you ever been to Colorado and you go, wow, it's so nice and toasty today. Let's go up to the top of Pikes Peak. And you head up Pikes Peak on the cog train in your short sleeve shirt, and what happens by the time you get up there?
Cold.
It's cold because as you go up, the air gets thinner and it gets colder. So can you see what happens? This water vapor, as it goes up, it cools off, and cold air won't hold as much water vapor as warm air. So it turns into, well, first it turns into a cloud, and then when the cloud has soaked up all the water vapor it can, it has no choice but to let it go, and that was probably not a good word I used the other day, belch it out, thunder into the earth, and that's called rain. It just comes falling down on us. Wikipedia, again, had some good stuff on rain. Precipitation is any product of the condensation of atmospheric water vapor that falls under gravity. The main forms include drizzle. Have you seen drizzle? It's not really raining, but it's just drizzling. Have you seen rain? Yes. Have you seen sleet? Have you seen snow? Have you seen grapple? Grapple. Have you seen hail? Have any of you ever been caught in a hailstorm? Oh, let's go out and catch a hailstone. Bad idea. If it can dent your car and break your windshield, it's probably not a good idea to reach out and try to catch one. Let's see what grapple is. Did it tell us?
Soft
Grapple.
or snow pellets.
Oh, figures. Grapple, it's a German word. It's also called soft hail or a snow pellet. It forms when supercooled water droplets are collected and freeze on falling snowflakes. Where have you seen that? Have you ever seen, it was snowing and then all of a sudden the snowflakes start to turn into something that's almost like a sleet storm, but it's real milky white? Well, that's grapple. You go, I don't think I pay much attention to it. I just think, hey, something's happening outside. And that's the word for it. It's when water is freezing around a snowflake. Well, that's enough of that one, isn't it? Do they have some nice pictures here? Pictures are always worth 1,000 words. What is this picture all about? What is this showing? Can you tell?
Countries by average annual precipitation.
Well, countries by average annual precipitation. So, it looks like, see how dark green the United States is? See the color green? Can you tell there's a little bit of, well, just look at your globe. Get your little globe and say, okay, here's the United States that has this rain. Where else do you see that kind of dark green? Looks like over here on the other side of the globe. Where is that?
China, maybe?
Yeah. Looks like it, doesn't it? China is getting some of the same kind of rain that we do. And Europe. Can you see in Europe some of the countries there? And does anyone have any idea about what all this rain does for us here in the United States? As opposed to the areas with blue where they don't get as much. We can produce more crops. Did you ever plant a garden and then it didn't rain on the garden? You had a drought that summer, and what happens to your garden? But if you have a garden where we have a normal amount of rainfall, you'll have more tomatoes than you can eat, more vegetables coming out of it than you can handle, because it's just the water, the amount of rain you get makes a very productive climate for growing food. All right, I think that's a. Is there another one here? Is there another thing we need to do about precipitation? Oh, wait a minute. I had something here. Yeah. I thought this was fun. I'll just come back up here at the top. I don't know what made me type this in here. Or maybe I was just looking at it and I saw it, but I'll go ahead and type this in here. Well, I think I will. Let's see if I can get that. Good. Let's erase this one and go, why does it rain? And of all the answers they have here, which one did I like? Why does it rain? Well, which one is it? Maybe that's it. Let's try it and see what happens.
Let's look at the science of rain and how raindrops fall. First, we'll need the sun. When the sun shines on water on the Earth's surface, the heat of the sun warms the water, turning it into an invisible gas called water vapor. This process, the changing of water into a gas, is called evaporation. Because gases are lighter than liquids, water vapor rises up into the sky. And the further you move up and away from the Earth's surface, the colder the temperature gets. So in the sky, the water vapor cools and changes back into tiny water droplets. This change is called condensation and is the opposite of evaporation. Clouds are made up of tiny water droplets, so when condensation occurs in the sky, clouds form and grow. Let's take a closer look. When water droplets bump into one another, they stick together and grow in size. They continue to grow until they are too heavy and fall as rain. They even grow as they bump into one another on their journey from the cloud to the ground. And every single raindrop that reaches the ground is made up of 1 million of the original tiny water droplets.
I don't know who counted them,
Raindrops fall on the ground surface where the sun can shine on them, and the whole process happens again. This is called the water cycle and keeps water moving from the ground to the sky, providing the water needed for plants, animals, and people to survive. So now you know.
So now you know. How cool is that? And did you notice the water coming down that little river back into the Gulf of Mexico for here, or back into the ocean on the east or the west coast? Now do you see why that little globe shows that all that clear area on your globe is water? Because when the water evaporates from the ocean, this is funny. I mean, interesting to me. You can't drink the water in the ocean, and you can't use it to irrigate your plants because it's too salty. But when the water evaporates, it doesn't take the salt with it. It just takes the water, goes up into the clouds, comes ashore, comes pouring down rain, and we catch it and drink it and use it to grow our crops. And then it goes back into the ocean and goes through that cycle all over again. So now you know. Oh, did you notice how the little droplets accumulate in the clouds, and as it gets higher and higher and higher, it gets cooler? So the cooler it is, the less water vapor the cloud will hold. Well, let me show you something else I found here. Let's see, maximum moisture carrying capacity of air. I know that's a lot, but that's what it took to find this. Maximum. What did I say? Maximum what? Where'd it go? Moisture. Maximum moisture. Ah, there it is. That's why we use Google, right? Because it pops up stuff to finish our sentence. Maximum moisture carrying capacity of air.
There goes a mouthful.
And where is it?
I thought you just said maximum moisture. You said
Maximum moisture carrying capacity of air.
A whole lot.
Well, can you read this chart? That's one thing. I try to find charts that's big enough where you can read them. But if not, you can go look at them. But look what this says. Okay, what's the temperature outside today?
46.
46. So go down here to 46 degrees. So let's call it 50 degrees Fahrenheit. And how much water can the air hold at 50 degrees? See that 9? Okay, just say, does that say 9 or 6?
Or 0.
It's 9. So let's drop the temperature down to 23. Now how much water will the air hold? 3. So you see what happens? When we go from, like, what would you say, 48 or something, or 40, when we go from 50 down to 23, we drop, what, 27 degrees? And the capacity for the air to hold water decreases by, it's 1/3 of what it was. It was 9, and now it's down to 3. So it's the air's capacity to hold water diminishes quickly as the temperature drops. So that means on a real hot day, a lot of water can be held in the clouds. And then as soon as they get high enough and they cool off enough, they can't hold that much water anymore, and the water falls out as rain or snow. You say, snow? Yeah, because if you're out in Colorado, then it's hot out here in the flatlands. The water goes up into the air. The clouds, because of the circulation of the earth, the clouds float toward the mountains. And what happens when they get up there above the mountains? It cools off and they drop the moisture, but the top of the mountains are cold enough in summertime to where it comes down as snow. And if you pump the temperature up to 85 degrees, it'll hold 30. At 50, it'll hold 9, and at 23, it'll hold 3. You follow how you kind of just round those numbers off and get the big picture? So that it is, so when you see that cloud and those droplets coming out, at those higher elevations where it's cold, there's a lot of water vapor that goes into the atmosphere down here where it's warm. Then when it gets up there, it cools off real fast. All right, so page 47 to 82, or 47 to 52, talks about causes of precipitation. And I think at the bottom of page 47, basically it's the movement of air that causes precipitation. You understand what they mean by that? As the water vapor goes up into the air and the air moves up and then moves across the land or moves from out on the ocean up on land, then they talk about convection and orographic uplift and frontal uplift. And I watched the weatherman trying to figure out the geography here, and I'm still not sure I understand all that stuff they say about how a warm front and a cold front and it's going to cause a storm. I'm not sure I fully understand it all, but basically what's happening is some things are happening in the atmosphere that's causing the air to cool off up there and drop the moisture that it's been picking up from down here where it's warmer. But they talk about them separately here on page 48, convectional precipitation, frontal or orographic precipitation, and it shows some pictures. That really helps too. And frontal precipitation. Page 49, right-hand column, bottom of the page. This is when a cool air mass, such as the continental polar air from Canada, meets a warm air mass, such as maritime tropical air from the Gulf of Mexico. Oh, that helps explain things. Think about where we live here in the Midwest. Look at your globe. What's south of us? The Gulf of Mexico. What's north of us? The North Pole in Canada. And you follow what happens? When cold air from the north comes down, warm air from the Gulf is moving from the south. Warm air is coming our direction, and because it's warm, it's full of water vapor. When it gets up here to Kansas City and it collides with a cold air mass from Canada, then it cools that air off, that warm air, and once that cold air cools it down, it can't hold all of its water vapor anymore, and it starts to drop it as precipitation, which we call rain. And I remember this book, as I listened to the weatherman talk about it, this book, that paragraph on page 49 really does help give a good picture of it, and then the pictures on page 50 help a little bit too. Page 52, we have to finish this chapter today, so we just have to keep moving. And again, as I said on the first day of class, if you come across something in a book that's confusing and I haven't talked about it, just send me an email or say something in class and I'll make a note to look some stuff up. But on page 52, just to show you, I opened my book up to page 52 and I said, okay, we need to talk about circulation patterns a little bit. And what are circulation patterns? Well, let me just Google something here. Back up here to my Google. And type in. And what do you think I'm going to type in? I don't know. What am I typing in? Global atmospheric circulation. global atmospheric circulation. Is that all? That's all. There it is. Global atmospheric circulation, a 2.5 minute video.
In this animation, we're going to look at global wind patterns and talk about the reasons why the air circulates the way it does, and also patterns of rising and sinking air and how that relates to precipitation. The engine that drives it all, I guess you could say, is the intense heating by the sun that occurs in the equator areas where the sun is shining at a very high angle of incidence. And this hot air near the equator, being less dense, rises upward. It rises upward and it moves toward the poles, and then it gradually sinks at about 30 degrees north and south latitude. So we create these big spinning circles of air that we call the Hadley cells. Now, near the equator where the air is rising, it loses its ability to hold moisture, and you get a band of high rainfall and low pressure because there's air leaving the equator. Where the air sinks, in these belts at around 30 degrees north and south, you get high pressure sinking air, which creates areas of clear skies and desert climates. Now, as this air circulates and tries to flow back toward the equator along the surface of the Earth, or as some of it heads toward the North Pole or toward the South Pole, the Coriolis effect, the spin of the Earth, causes it to bend and turn, and it's going to create the two big wind belts that prevail on our Earth. 2 out of 3, the trade winds, northeast trade winds and southeast trade winds, and then the prevailing westerlies. Now these winds curve in the way they do because of the Coriolis effect. The winds curve to the right of their path, north of the equator. They curve to the left of their path, south of the equator, and they end up flowing from east to west or from west to east. Now the other big factor is what's happening at the poles. At the poles, the air is cold, and the cold air wants to sink. And as that cold polar air sinks, it heads toward the equator and it bumps into this air heading toward the pole here and toward the south pole here. And it creates an area of rising air, and again, rising air produces high precipitation belts at about 60 degrees north and about 60 degrees south latitude. At the poles themselves, the precipitation is quite modest because the air is sinking, and that creates low precipitation.
Did that help? Now, see, the thing is, you can find this stuff at home and watch it as much as you need to. Did they say?
I'm Paul Beckwith.
No.
I'm with the University of...
Oh,
In this
by the way,
animation, we're going to look at global wind patterns and
look
talk
at
about
this.
the reasons why the air
See this one here?
the way it does.
It has
Also, patterns of rising
489,000
air
people have
and how
looked
that
at it.
relates to-
That guy that just came on there, I started watching him because he popped up first for some reason. I don't know if he pays money to pop up first or what, but there's only about 38,000 people have watched him because he'll bore you to death. And I'm just saying, if you Google this stuff and you start looking at something, you go, that one's no good. I'm going to watch a different one. But one way you can tell where the quality ones are is where there's a lot of people watching it. If 800 people have looked at that, that's obviously a worthwhile video. Okay, now he said one thing in there that I wonder if all of you understood. I mean, you understood precipitation, you understood the cold air, the water droplets falling out. You saw how from the equator, the angle of incidence where the sun is directly on it, so it heats it up more than the rest of the globe. So the air is rising there and getting up there and cooling off and circling around. But did you hear him talk about something? Did you hear him use a word? He called it the Coriolis effect. Do you know what that is? Now the book talks about it somewhere. Oh, on page 53. But while you're looking at page 53, I'm going to type it in here. C-O-R, I thought I was. C-O-R-I-O-L-I-S. So go ahead and read what it says there. E-F-F-E-C-T. And and which one is it? The Coriolis effect. See these videos here? Well, I've looked at all of these, but the one I like best is the one I'm going to show in class. By simply
The rocket
put,
equation. It's a beautiful thing.
No astronaut launches for space with their fingers crossed. That's not how we deal with
the reason we get this stuff free is because we have to listen to ads.
Picture a circle. Here's its center, here's point A, and here's point B. Point A is twice the distance from the center of the circle than point B. Oh yeah, and it spins from its center. In 2 seconds, both points do one full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And we all know if something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be moving faster than point B. Okay, now swap out this flat circle for the Earth, and the same thing is true. All points closer to the center, say like someone in Greenland, will be spinning slower when compared to points spinning further away from it, say like people in Brazil, closer to the equator. So if we look at it all flattened out, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line, like we just observed. Now imagine you're a cloud that formed here on the equator. You'll have the same velocity as the Earth, but then a gust of wind sweeps you to the north, where the Earth isn't spinning as fast. Due to inertia, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower, so you, relative to the ground, move ahead of everything else. If you're a cloud that forms at the 45-degree line, you'll also have the same speed as everything around you. But if you drift down to the equator, you'll be moving slower than the ground underneath you, so you'll
That's
fall
why the book
behind.
shows
And
those
the same
curving
things for the southern
lines.
hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now imagine a low-pressure cell. That means all the air around it will get sucked into the center. But the air coming from the equator will be traveling faster, so it will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are, low-pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low-pressure cell will still suck in the surrounding air, but now the air coming from above will be moving faster, again deflecting to the right, while the air coming from below is moving slower, again falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way. And that's about it. It's a short video, and that's kind of the point. I hope you got what you came for. And the Coriolis effect doesn't really influence toilets, they're just really too small, and the direction of the spin more depends on the placements of jets inside the toilet. But that's it, that's the Coriolis effect. If you like this short and to the point video, give this video a like, and if you want to see more videos like it, why not subscribe? I'll be back next week with another video, so until then, thanks for watching.
Well, thank you for giving me a headache. I mean, don't you kind of go, whoa, whoa. It's just like they give me so much information, it kind of becomes overload. And I'm just telling you that if you look this stuff up, once you find this stuff, you say, you know what? I'll bet if I watch that 3 or 4 or 5 times, it would eventually start to sink in. You go, I have a lot going on. I mean, I didn't take this class just because all I wanted to do was study geography this 8 weeks. I'm just working on a credit along with others, and I understand that. But do you understand how you can use the internet to help you grasp this stuff? And for those who are going to be teachers, can you see how you can go on here and find things for kids and use this to help them see what's going on? And some of these videos, probably if I was showing this one to younger children, I would show it maybe one day, and then 3 days later show it again, and 3 days later show it again, and have them talk about the components of it. But see, what happens is when you're doing this stuff, and this is how I want you to work through this book. I want you to read every word on every page, and then when you come across something that goes, I'm not sure I get that, then ask me a question, so I'll go find the videos, because that's all I'm doing this semester is teaching geography and math, and I have nothing else to do except sit at home on my computer. My wife comes by and she goes, "Are you still working on geography?" And I'm going, "Yeah. I'm having so much fun in here. Just trying to find the best videos and the best web places to go to help you get a handle on this stuff." So don't hesitate to send me an email and ask me a question about something. I wouldn't be doing this if I didn't like this stuff. I know. Page 58. There's the picture on page 54 of what we just saw with this Coriolis effect. Is that Coriolis effect? See, these are words I don't use them all the time either, so it's like, okay, Coriolis effect. What did I say? Page what? 58. And page 56 is some more pictures. And there again, it's like, whoa, it's giving me a headache. It's just like, it's a little overwhelming. But it's just showing some of where these little places where these, what low pressure areas in the summer and in January and July. Why did I have you go to 58? Oh, on page 58, it shows a picture of the globe with these oceanic circulation. Not only does the air have these circulation patterns, but the water has circulation patterns too. Did you know that? Now, see, the people, did Columbus know that? Yes, he did. That's why he said, we can follow these currents. In fact, somewhere on the internet, I found a picture of a globe of the earth that Benjamin Franklin had drawn. And on that globe, he had, like, somebody asked about these little blue lines here. What were these all about? On that globe, Benjamin Franklin had drawn we call it what, the Gulf current. He had drawn a picture of how the oceans has this circulation system where you get in the water here and you can ride the circulation system around and come to the United States and then ride it back and go back to Europe. And those early sailors knew about that stuff because they would actually see what was going on. I think it shows a little bit of it here on page 58. See the Spain and Portugal down there, and see how those little red lines go down and around toward South America, and then they curve around and come along the eastern seaboard and then back up. And if you ride those currents, you could I think some people have done that. In fact, they got in a little boat and just rode the currents from England to America and back again, to just for the fun of doing it. Now there's a guy who is a lot more bored than I am. That's pretty amazing stuff. Oh, and this El Nino on my Twitter account. Some of you have been there, haven't you? I know, because you've looked at it. Because I noticed my friends list has increased up to 14 now. I have 14 friends on Twitter. So if the guests want to check it out, it's called CBC Geography. And then it'll pop up and say Tom Bonide, and you say that must be the one. You click on it, and sure enough. But I found a video when I first started teaching this class. I found a video on explaining El Niños that is just amazing. So we're not going to take time to look at it in class because we have to finish this chapter by the time, in 30 minutes, by the time we dismiss you to go to chapel. But you can go to my CBC Geography Twitter account and scroll clear down to the bottom, because I think there's like 80 or 90 of them on there now. I mean, you know, these pictures of hurricanes we saw. Do you realize that we just had a hurricane in the Midwest. They called it some kind of bomb. This thing, have you seen pictures of what's happening out in Colorado? It's a mess out there. And basically, we have a hurricane that just landed over the land area, the same kind of effect as a hurricane, and that's what's causing all these wind problems and wind damage and all these big blizzards. And I see some of those pictures and I'm going, wow, that will be good for geography class.
How does that happen?
What?
How does that happen?
And how does that happen? It's like, okay, see, just like they say that there's a low pressure area,
Yeah.
and then there's the wind blowing around this low pressure area, and all of a sudden it starts those, can you see where because of the currents in the ocean and the wind currents, it starts to blow in a circle? And then once the circle gets started, it just gets stronger and stronger and stronger and bigger and bigger. The same way with tornadoes on land.
Yeah.
But out there in the ocean, and of course, how come we had a hurricane over land?
Yeah.
Because all of those big wind currents out in the ocean blew this direction for some reason, and the other thing is that the low pressure has to be really low to what would you say, to birth a hurricane. And it's like the weathermen said that the pressure was so low here in the Midwest, it set records for, it's never been that low before. So that got so low that it created that hurricane effect right here over land in the Midwest, and just has created all kinds of havoc.
That's very interesting.
So now we're ready for, so you can look at El Nino on CBC Geography. And now we're ready for 62 and 60 air temperature. Page 62. Air temperatures. Showing what the temperature is, average July and average January temperatures in North America. So if you look at this little chart here, the one for average July temperature, take your little globe and put your finger on Kansas City and look to see where we are on that picture. And you go, oh, so in the summertime, I call my relatives down in Oklahoma and I say, is it hot or what? I just saw the weather report. It's nice and cool up here. So now look up at the top. In the wintertime, what does my brother do? See, we're right on the edge of that blue, and he's in Oklahoma City down there in the white. He calls me and says, hey, we're having nice weather down here. What about you? And I'm going, it's freezing cold up here.
That's messed up.
And if you leave here, you put your finger on Kansas City, and then you go from Kansas City to Chicago. Do you see how it's a lot colder in Chicago than it is here in Kansas City, generally speaking? And that's what you can look at this. And then if you go clear up north, since my kids used to be missionaries in Moscow, I go up north from Kansas City, clear up here to how cold it is up by the Hudson Bay. And I'm going, oh wow, up by the Hudson Bay, that's up here. And I go around and I'm going, whoa, that's where Moscow is. So if you were to turn the globe around and bring Moscow around to where we are, it would be up there near the Hudson Bay where it's really cold. So you can kind of get a sense of, and I said to my daughter and son-in-law when they were in Moscow, I said, why in the world would Russia, with all that landmass over there, I mean, look at how, look at Russia. all this area. Why in the world would they make their capital city up here when they could have easily have made it down here where it's a lot warmer? And my son-in-law said, well, when you study Russian history, the Russians will say, that's why the Germans couldn't defeat us when they attacked us, because they can't handle the cold weather. And on the news recently, did some of you see this? Some guy saw 2 dogs fall through the ice in a lake up north. He took his clothes off, stripped down to his shorts, jumped in the lake and rescued the dogs. And the guy interviewed him and said, weren't you cold? He goes, nope, I'm from Siberia. It's like, oh, that explains it. Those people in Siberia, I mean, down here, what, you do a challenge to somebody? They do a challenge, see how long you can stand out in the cold before you turn into an icicle. I mean, it's like they have a capacity for withstanding cold that is just amazing.
Oh man, I couldn't do that.
Just because they live with it all the time. So it's just like, okay, so for that guy, hey, it's not that cold, let's jump in that lake and rescue those dogs. And I'm thinking any of us would have said, if I did that, I'm going to die like the dogs are dying. No, you won't die. And then, of course, the guy from Siberia, here's what, so when he talks to Americans about it, he goes, you people are a bunch of weaklings. We're real men in Siberia. We can handle this cold stuff.
No, we just got common sense, man.
I tell you this, I read a thing about a guy went to Alaska to live with some Eskimos one time to learn more about their culture. And inside their Eskimo, inside their igloo, they had little benches around the edge of the Eskimo that were carved out of ice, and that's what they slept on. If your bed is made out of ice, I'm not coming to visit you. You come down and visit me where it's warmer. That's just crazy.
Praise the Lord.
So page 64, we've already talked about precipitation. Page 64 to 67 talks about Earth's climate regions. I just have to tell you, this climate region stuff, well, let's just go back here and Google it. Have you read this section yet? Boy, if you want something to wear you out. The first time I read this section, I thought, remember, did any of you ever have to collect bugs? Get a bug collection when you were in high school? And then you had to, after you collected the bugs, you had to look up their phylum and species, and you had to do all this research to find out how they fit into the labeling system for bugs.
They just gave us pictures.
They just gave you pictures. Well, see, I thought it was fun catching all these bugs, and then when the teacher said, now you have to do this research on each one of them to find out their family and all that kind of stuff, and it's like genealogical research is what it is for insects. Well, guess what we have here? When we come to Earth's climate regions, I just type in Earth's climate regions. And watch what I see. What are the 6 major climate regions? Let's see if it's going to tell us. Nope, I don't want that. That was a mistake. All those pictures will just wear you out. What are the 6 major climate regions? The polar chill, the polar region, the temperate regions. Oh, look at that picture on page 65. Do they have names there for them? The polar region is down at the bottom. See that? Do they have temperate regions on there? Well, what else do they have? Do they have arid regions? That would be dry climates. Do you see that on the page, on page 65? They're not all using the same labels. And then tropical. Is that listed? There, tropical's at the top. And then mild Mediterranean and cold tundra. Now, see, the textbook says polar climate and it shows tundra. And then it shows Mediterranean under mid-latitude climates. Do you follow that? It's like, no wonder this is confusing. Not everybody agrees with how we're going to talk about this stuff. But what's neat about this one, what I liked about this, even if it doesn't match up, look what it says. Polar climates are very cold and dry throughout the year. They encompass the South Pole, the extreme northern latitudes, and the interior of Greenland. Plant life is non-existent except for some algae, while the few animal species, including polar bears, killer whales, seals, and penguins. Temperate regions, cold winters and mild summers, and covers much of North America, Europe, and the northern parts of Asia. You see how they give little descriptions here of this stuff, so you kind of get a picture. Here's a name, and you kind of get a picture of what it's like to live in that region. Temperate grasslands are dominated by flowering grasses and are populated by such fauna as lions, wolves, zebras, foxes, snakes, and deer. Well, it looks like the African temperate region has lions, wolves, and zebras. The American temperate region has foxes, snakes, and deer. You follow what happens? It's like they're taking this temperate region and going all around the globe, going all the way around. In fact, I don't know whether page 65 is more helpful or whether page 66 and 67 are more helpful. Let's run through this list again. What do we have down here? The cold tundra. Do you see tundra on here anywhere?
Yeah.
Yeah, there it is, over there on the right-hand side under polar climates. Right up there at the top. Do you see that? Mm-hmm. Up at the top of that picture on page 67. The mild Mediterranean. Do you see Mediterranean anywhere? Yeah, under C, warm mid-latitude climate. And do you see what that green color? See, any idea why the book, this is calling it the mild Mediterranean? What's that body of water that's surrounded by all that dark green area?
The Mediterranean Sea.
The Mediterranean Sea. Mm-hmm. So that's why these people said, we'll just call it the mild Mediterranean. Have any of you ever lived in the Mediterranean area?
Mm-hmm.
Well, how come they don't have air conditioners in the Mediterranean region? Window air conditioners. You don't need them. It doesn't get that hot. Why don't they have a furnace? Because it doesn't get that cold. Whoa!
They consistently get to have
Take
good
me.
weather.
What?
They consistently get to have nice weather.
They consistently have nice weather.
Let's move the Calvary up there.
Yeah.
That's not even cool.
And it's just like, whoa, what's this all about? Now, you say, no, I've been to Greece and I stayed in a hotel and it had both air conditioning and the furnace. Yes, because tourists from the rest of the world aren't acclimated to living with that range of temperatures. And the range isn't very big either. Can you see where it's like, hey, when we were in Greece visiting some friends on, what was that island? Kalymnos. They lived on Kalymnos, and we'd go to bed at night and it'd be nice and cool, and they'd go, oh, it's cold. I'd say, you guys don't know cold. Then in the morning, in the middle of the day, they say, oh, it's hot. I go, you don't know hot. And it was just like, this is so cool to be in a place where at night it never gets so cold maybe you need a blanket once in a while, but it never gets so hot in the summer. I mean, if it got a little warm, you just find a shady place and you're okay. It's just, so that's why this book calls it the Mediterranean. The damp tropical region. So see, mild Mediterranean, I like that label because it is a mild climate. And remember that thing where we looked at daylight and darkness? You can also go on the internet and we typed in Kansas City, you could type in Athens, Greece, and it would show you the same thing. And you can go to Google and put in stuff like, what's the temperature range? And you can get the temperature range for Kansas City and the temperature range for Kalymnos. But see, it's mild. And then why is the tropical region called damp? Is tropical region on this map?
Mm-hmm.
Do they say tropical somewhere?
Yeah, the dark red one.
Where?
On page 66.
On 66? Ah, there it is. Seasonally humid tropical. But have you figured out where that area is? See on that picture where it says equator? Right around the equator is where you get. Have you ever been someplace close to the equator? Okay. I go to bed at night, and at the top of the wall, there's a space about this wide between the wall and the ceiling. I asked my friend I was staying with, why is that? He said, because if the house was completely closed in, it would get so humid in here, we would have mold on everything. So we keep the top open so that air circulates and keeps mold from building up. Well, guess what else? If you have a place where the mold won't build up, you also have a big space where critters can come in. And every night I went to sleep in Brazil, I just said, Lord, I know the little critters have to eat, but please have them take their food off of someplace other than my face. And I'll see you in the morning. Hopefully. I mean, it's just that part of the world.
If you pull your bed away from the wall, they tend not to climb on you.
Yeah. Okay, see, no one told me that. They just wanted to mess with me while I was there. And what I actually, you know what I discovered? Okay, where I was in Brazil, all the native Brazilians didn't sleep in beds like we do here in the States. It would get too moldy, too much mildew. They sleep in hammocks. And I'm going to try one of those. And then I was up in this area where the bugs couldn't get me. I fell in love with hammocks. I filled my suitcase up with them and brought them back home, introduced my whole family to hammock living. I'm telling you people, I mean, think about it. You don't have to have a bedroom. When your company leaves at night, you have hooks on the wall. You just stretch your hammocks out right in the middle of your living room, and everybody crawls in their hammock and goes to sleep. And maybe I liked it because everyone has his own hammock. I had to grow up in a family where there's a whole bunch of kids, so I had to share a bed with a brother. That's bad news, especially if he's older and bigger and stronger. But that damp tropical region, just wear you out. All that moisture. But you could go out in a rainstorm and play soccer, and the rain was just as warm as it could be.
Until you played in a mud puddle.
Yeah, and why do you think that's called arid zones? What's arid about it? Have you ever been to a desert? Well, can you go to a desert here in the United States?
Yeah.
Well, it looks like
Arizona.
you can't go to a real desert, that light tan stuff, under dry climates, but you can go to semi-arid desert. Oh yeah, you can find some real desert there. Guess what we call our desert in the western United States? Death Valley. Any idea why it's called Death Valley?
Somebody died.
Because people die there.
There we go.
It's like, how could you die in a desert? What's the one thing that will kill you in a heartbeat if you don't get enough of it every day?
Water.
Water. If you don't stay hydrated, you're toast.
Literally.
And people go out in the desert, yeah. You dry up and turn into a little slice of bread. And it's arid. And see people go, oh, I don't need any water. I'm just going for a little walk.
What?
Well, they get out there. And fortunately, our government spends a lot of money paying people to take care of dummies. And they have these desert rangers who drive around rescuing people who don't have the good sense to do their homework before they go for a walk in the desert. Temperate regions. Did they use temperate on this map? No, they use what? Warm mid-latitude and cold mid-latitude. And see why it's called mid-latitude? Because it's not tropical like on the equator, but it's a little north and a little south, and it's really a comfortable place. And you know what's kind of fun about this spread out map here on page 66 and 67? You can kind of take your fingers and go across here and cross these regions and then see how much land is involved in each area. And see how much of the world is affected by that. Okay, now let's go back to 6 major regions. Nope, let's go back again. There we go. What are the 6 major regions? Well, it's not showing up here. So I'm just going to tell you about it because we only have 10 minutes left. I got too busy talking about this stuff. I found one that said 3 major regions. 3 major regions. And here's what they said. Polar, temperate, and tropical. And you see you would have polar to the north, then temperate and tropical. And then polar to the south, and temperate and tropical. And what they're saying is that they don't disagree with the people who make 6 or 5 or 7, whatever it is, but they say, but these are big regions, but each region can be broken up into smaller regions. Just like on page 66, okay, look at the Mediterranean. We talked about how cool that is. If you want to taste the Mediterranean living, look at the United States map on page 66. Oh, you don't have your book yet. Oh, wait till you get to see it. Okay, tell him on page 66 where he could go to get a taste of Mediterranean living. Where could he go?
California.
California. See that real dark green area on California? That's the same color as the Mediterranean. So you don't have to go to the Mediterranean, although I will say it's much more fun than going to California. But you can go to California and get a taste of the climate over there. Climate on Wikipedia had a ton of good stuff. Is that listed here? Just type in climate and type, and then when you type in climate, just go to Wikipedia. Click on the one that says Wikipedia, because Wikipedia has a real good explanation of climate. Because when you're trying to figure this stuff out, if you're looking at the pictures on page 66 and 67, and if you're reading things on the internet, it really does help kind of bring this stuff to life and make sense out of it. Well, there's one more thing I want to do, talking about this climate stuff. So let's see if I can find it here. See, it talks about the climate, but I thought, boy, it would be nice if I could find some pictures of it. So let's go, what? World climate. Get the rest of that out of there.
Good.
World climate, does it say pictures? Well, then let's just click on world climate and see what happens. www.blueplanet. Is that showing up?
Right there.
Ah, there it is. World climate. www.blueplanetbiomes. Now, I clicked on this one 2 or 3 times and thought, no, I don't like that one. But it does have some nice colors in it, showing the same thing. So I thought, yeah, that's kind of cool. And see how it's got tropical down there, and dry, and temperate, and cold, and polar. And can you see where now when I see the word temperate, I know the book is calling that, what, mid-latitude warm, mid-latitude cold? So now you're getting a handle on this whole scheme of thinking. But look at this. Where'd it go? Here's a picture of tropical moist climate, a rainforest. Ah, here's a picture of a tropical climate savanna. Here's a picture. What is that? Well, I know that's a desert. I've seen pictures of that before. Here's mid-latitude, dry mid-latitude. Oh, I know where that is. That's up there where those guys live in, you know how they raise reindeer and cattle, and they live in these little portable houses that just go looking for new grazing for their stock. What's this one? Mediterranean climate? Well, that doesn't look very appetizing. No, but the weather there is marvelous. Maybe that's not the best picture, because the part of the Mediterranean, the picture I have of the Mediterranean, is they had all of this stuff growing everywhere. Kind of like in Brazil. When I was in Brazil, there's fruit trees everywhere. If you're homeless, go to Brazil, people. If you want to live homeless someplace in the world, live in Brazil. There are fruit trees everywhere. And they don't mind if homeless people take up some space that nobody's using and build a camp. Dry Mediterranean climate, grassland biome. See, every time I see grassland, I stop and look at it, because where did I grow up for the first 18 years of my life?
Grassland.
On a farm in Oklahoma, Grassland, USA. My ancestors, when they moved to Kansas and Oklahoma, lived in sod houses. Anyone know what that is? It's where you dig up chunks of sod, grass, like, you know, they grow grass and then lay it in your yard. Well, they would take those chunks of sod and stack them up to make walls, and then find some way to put a roof over it. You go, ew, that's disgusting. I'm going, well, you know, what else could you do? Dig a hole in the side of a little hill and live in a cave. You go, well, why don't you just order out some lumber and build a house? Well, there was no lumber to order out. Well, why don't you cut down some trees? You know what happened when I first moved to Missouri? I got claustrophobia. With all the trees around here, it's like, whoa, whoa, give me some wide open spaces where I can have a little breathing room. And now I've lived here long enough with all these trees. I go to Oklahoma and I'm going, wow. People used to say it's miles and miles of nothing. They were right. It's like, no, it's just a matter of what you get acclimated to. But you see that grassland? It just has an appeal to me. Deciduous forest? Yeah. Now see, it used to be that picture would give me claustrophobia. And now I just love to walk through the woods in the state of Missouri. Can you walk through the woods in Oklahoma? No. There are no woods to walk through. You go, oh, wait a minute. We have some trees. My brother could say that. We have some trees. I said, yeah. Let's see. You live on 160 acres and you have 5 trees. One big cottonwood and then a few brambly ones growing next to a creek. That is not woods, brother. You want to see some woods, you come up here and I'll show you some woods. Group 3, high latitude climate. There again, the best thing you can do is if you're ever in Colorado Springs, get on that cog train and go to the top of Pikes Peak just to get a feel of what it's like to be up there where the air's thin and where it's cold. Tundra, oh man. Highland climates, it's all over. So this is the best I could find was pictures under www.blueplanetbiomes.org. If you find some pictures somewhere, and I tried to upload this to my Twitter account and it wouldn't let me tweet it, so I couldn't do it. Well, there you go. All right. On Monday, are you coming to class on Monday?
No, next Monday.
Are you coming to class the next Monday?
Monday
A week
after
from
next.
then? Well, have a good time, because I think spring break goes through the following Monday, doesn't it?
Yeah. Oh, it does?
Okay.
Well, aren't you glad you learned that today? So you show them, good. Where is everybody?
I wanted
They're
to.
still on spring break. What's that all about? I don't know. They just picked the Monday because of the choir tour thing, I think, is how it all got started historically. But basically, that means we won't have class again till the Wednesday. And on Wednesday, we're going to do chapter 3. I'm going to stay on schedule, even if I don't finish it all. If I show you too many pictures, that's too bad. I'm just going to show you what I can to help you understand it. If you get hung up, send me an email. And have a nice spring break. Go, if you get bored, go click on my Twitter account and look at some geography stuff.